When we need to find a match for somebody, when we were doing the swabbing event here today, we take, they do a swab of the inside of their cheeks, which takes cheek cells, and we test them, and we get 6 markers out of that. If somebody matches that, we call them in for a blood test, and I believe we match 4 more. So 10 out of 10 would be a perfect match. I believe, and you can speak on this, but it would be ideal if you had a 10 out of 10 match. But I know you do transplants if it's a bit lower too. And I'm not sure what, 9 out of 10?
Or half.
Or half, okay.
Either a rated half match or 9 out of 10 under.
Okay. So that's basically what we do when we collect swabs, is we get those first 6. And then once we send that to the transplant physician and they decide they want to take that, that team wants to use that donor possibly, then they call them in for the blood test. And we send that blood test to the hospital that they're working with.
So the blood test serves 2 purposes. One is to extend the matching, but also to confirm that the information from the cheek swab and the blood, which will eventually get into the patient, are the same person. But you have to have it to check. If you don't want to give a person cells from the wrong person, the shipping cells from the wrong donor. Do you ever put your
what is the...
Oh, cellular therapy. So one of the really emerging cellular therapies right now is CAR T cell, where the T lymphocytes of the patient who has disease are grown up and a virus is put into them that expresses on the surface of those T cells an antibody that recognizes some foreignness or characteristic of the cancer cell. So this is not only being used for leukemias, but it's being used for melanoma and glioblastoma. So a whole range of cancers are now being treated with these T cells that can recognize a protein on the cancer cell and attack it. And the protein that's been engineered is also jazzed up so that it really turns on that T cell. It really makes it kill it. So people get very sick for a while, but we are seeing cures of people with the CAR T. My sister had it for CLL. She's doing well. Sometimes the CAR T is a bridge to transplant because the leukemic cells can be smart and they can lose the protein that's being attacked. So what's now evolving is putting in several different viruses attacking several different proteins that may be on the cancer cell. So that if one gets shut down, if one of those targets disappears, there's still another target. But this is an area that's evolving very quickly. And immunotherapy. So really, I guess transplant was the first form of immunotherapy that we had, and we've learned from transplant. We're trying to do away with some aspects of that, but still get the immune benefit of the attack by T cells.
Oh my goodness, this is quite interesting and exciting, as a matter of fact. My understanding, Dr. Minden, is that, and I know we have kind of progressed in terms of your age, the age range that you will do a transplant. There's some issue around whether you're up to 60 or 65, I don't know. Is there an age barrier with the cellular therapy as well?
I think age is controversial.
That's right.
I think that we are pushing well into the 70s now with these therapies. I think that the concept of how old the person is has to be based on their biology, not their calendar.
Excellent. Good answer.
I'll take that one. And then I'll get back to Chester and Tom. Another thing for you, Doctor, I mean, when you talk about markers or Chris, what exactly are these markers that you are looking for?
In English.
English? Oh, I get HLA, human leukocyte antigen, is a complex of genes on chromosome 6. So each of us has 2 chromosomes 6. We have HLA A, B, C, D, and E, and there are variants of each of those. So remember I said there were hundreds of different types of proteins in this HLA complex. So what is done when the cheek is swabbed is DNA is made, and it is sequenced for these proteins. It's always sequenced for these proteins. It's not being used for other aspects of sequencing of the donor's DNA. So just the HLA is looked at, and we then classify what type of A person has, B, C, and D. And then we can try to match those up with the potential recipient.
Right. Tom, you went through a stem cell transplant. Do you want to tell us a little bit about what that was meant to you as a patient? Did you have any rejection? How are you now coping with that?
Okay, so in March of 2015, that's when they found me a donor. It was unrelated and it was not at a 10 HLA. And then I had to prepare my body to chemo as well, but as Dr. Minden said, the patient's also being prepared to soup up his stem cell counts. So when those two correlated, that's when I was called in to do the transplant, to have the transplant performed. That was in August of 2015. I just recall thinking that I had to go into this as healthy as possible. So I worked as much as I could. I knew that the radiation and the chemo I was going to receive was going to just tap me out. So I needed reserves. I don't even know if that made a difference, but in my mind, one of the first things I asked for in my hospital room was a bike. So I was on that bike every day, and I was in the hospital for close to a month. The day of the transplant, it was a glorious day. My family was with me, God was with me. I was picturing